Hello guys, welcome back to another video of An Average Programmer. Today I'm going to be solving the problem 1367 of LeetCode, which is linked list in a binary tree. This is marked as a medium problem, but I would say it's more on the easy part. So I'm going to be reading the problem and also showing you the solution, which is really easy. Okay, so let's start reading the problem. Given a binary tree root and a linked list with head as the first node, we need to return true if all the elements in the linked list starting from the node head correspond to some downward path connected in the binary tree. Otherwise, we need to return false. If we see these variables are the ones that we receive in our function, so here they are, and also we have the definition for a downward path. A downward path means a path that starts at some node and goes downwards. And that is what is happening in our first example. We receive the head of our linked list. It starts with 4, the next node is 2, and it ends with 8. Okay, so if we see, these nodes are included in our binary tree. Okay, and here the downward path starts from the first child of the root of our binary tree. Okay, so we return true. Let's see this other example. For our linked list, it starts with 1 and it ends with 6. If we see these nodes are obtained from our binary tree. Okay, so in this case, the downward path, it starts from the root node of our binary tree. So we need to return true. Okay, and yeah, so the solution is really easy. We just need to parse our tree into a string, and also we need to parse the linked list to a string. Okay, so if we have those two variables, we can use the function includes from JavaScript to just return if the linked list is inside of the binary tree. Okay, so let's create those functions. I'm just going to be creating this first function for parsing the tree into string. So I'm just going to be receiving the node, which is going to be of type tree node, and the str in which I'm going to be concatenating the information of the nodes of my binary tree. In here, I just want to be sure that I will not be evaluating some undefined. So if I don't have a node, I'm just going to be returning that the str will concatenate the word nil. Why this? Because I'm going to be obtaining the different paths of my binary tree, and I just want to know at which point my path ends. Okay, because if I'm not making this, I will have a lot of values that will be connected, but I will not be able to see the different paths of the binary tree. So I'm just going to be doing this, and if I have information for my node, I just want to concatenate that to my str, which is going to be done by this way, which is str.concat the node val. Okay, and I'm just going to be doing the same for the left part, which is going to be this tree to string. I'm going to pass the left child and also the str, and I'm going to be doing the same for the right child. Tree to string node.right and the str. Okay, so I just want to return the left plus right. Okay, and I need to create a function also for the linked list. In this case, it's easier because we just have one next node for the linked list. So it's going to be linked list to string. I'm going to be getting the node, which in this case is going to be of list node, and the str in which I'm going to be concatenating the information of my node values. So if there is not a node, we just want to return str. Why this? Because if I concatenate concat, I don't know if it's concatenate or concat, please let me know in the comments. If I push the nil word in my str, I will have 4 to 8 nil, and that is not going to be existing in my binary tree. So I just need to return the str. And if I have information for my node, I just want to concatenate that. Then I just want to concatenate the node value for in my linked list string. Okay, so str.concat the result of my function linked list to string. I'm going to pass node.next, and I'm just going to put here the node value. Okay, so that's for this, and I just want to get my tree string, which is going to be obtained from the result of this recursive function. I'm just going to pass the root and an empty string for storing all the values of my binary tree, and I'm going to be doing also the same for my linked list, and I'm going to pass the head and also an empty string, and I just need to return if my tree string includes the linked list string. Okay, so let's run this to see if it is working. Okay, as you can see, this is accepted by the first test cases, and let's submit my my solution. Okay, so if we see the complexity, the time complexity is order of n plus m. That was all, and thank you for watching the video, and see you in another one. Bye.